All right, everybody, and welcome to Building SaaS on AWS, the SaaS Factory show for SaaS builders on Twitch. Every week, we bring on SaaS experts to talk about different aspects of building SaaS. So whether you're already building a SaaS application, whether you're operating an existing SaaS application, or whether you're thinking about how to take your application and deploy it in a SaaS deployment model, this is the show for you. And this week, we have on a very special SaaS expert, Mehran Najafi from AWS. And I'm Bill Tarr. I am part of the SaaS Factory, and I am your host for this episode. So without any further ado, Mehran, why don't you introduce yourself? I think probably an interesting fact for the audience, you've done at least 3 shows of building SaaS on AWS. You might be the record holder so far. I know a couple of other people are fighting for the title, but I think you're up there. Why don't you tell us a little bit about yourself, this interesting background you have of combining both SaaS and AI/ML, and sort of how you landed here, why you've become the expert in this space.
Sure. Hi, everyone, and thank you very much, Bill, for inviting me. I'm very happy to be here. Again, Mehran Najafi, I'm a senior solution architect with AWS. I'm based in Toronto, Canada. It's almost midnight here, so very happy to be here and talking to everyone. So my background is I'm working with lots of companies that we call them ISV, that they are building digital solutions. So I'm working with them, and more specifically in the AI/ML domain. And because those ISV companies, they are mostly in SaaS, so I got interest in this intersection of these 2 topics, AI/ML at a scale and SaaS. And thanks to ChatGPT and GenAI, so now we see more interest and more demand for AI/ML and generative AI. And I'm sure very soon we all need to look at it with the SaaS lens. It's time to exploring it, see that what it does and what are the use cases. But really, when you want to bring it into life, you need to bring a scale, and you need to make it as a SaaS solution. So that's why it grabbed my attention, and I'm very happy to talk about it today.
Well, and we're glad you did, because 3 episodes is a lot, considering we've done about 40. So this is pretty exciting to have you on. I really like the topic that we have this week. So this week, we're specifically going to be talking about building multi-tenant GenAI solutions on AWS, right? So this is building GenAI as a SaaS, essentially, right? So it's a really interesting topic. It ties the 2 topics that you've sort of gravitated together really well. But first, I mean, maybe there's some people out there who haven't heard of GenAI yet. I'd be surprised. I think it's affected most of our lives already. It's been all over the news. But let's start with that. And how will SaaS play a role in GenAI? How do you see these 2 topics overlapping right now?
Yeah, great question. If I want to simplify Gen or generative AI, I would look at it as a AI/ML model which generate like a digital asset. So that could be generation of text, like writing a novel, having a question answer like a ChatGPT that I'm sure most of us has tried it, images, videos, some prediction, or when there is a generation of something that computer can do, so we can look at and if you want to bring it with AI/ML, so we can look at AI/ML and GenAI.
Right.
So when you want to add that SaaS aspect to it, and what we have seen in the field, usually 2 different ways. One is that a company, a SaaS provider, they already have an offering, and they want to add some GenAI aspect to it. For example, like a company that provide mail services to their customers, right? So they want to add some GenAI features, for example, auto reply, right? So
right.
That's not their core service. The core service is basically just providing a mail service like an inbox and responding. But there is a very nice feature that enable their users to automatically reply to some of the emails. So that's one way of looking at GenAI in SaaS. The other one that probably is more focus of today's conversation is when we have GenAI as a service. So it means that a company that build LLM, and LLM, it is for large language model. That's basically that AI/ML behind GenAI. So those big multi-billion parameters, trained for GenAI application. So a company may have one, or they customize one. For example, they take one in the field of medical domain and then they customize it, retrain it, fine tune it to act for a very specific use cases. And then the company want to offer that as a service. So that bring the SaaS aspect into that offering. That is, the core GenAI as a SaaS. So,
Nice.
these two are very, very popular trend now with the
Right.
customers.
Right. So this differentiation between a service that you add to an existing SaaS model versus actually delivering Gen AI as a SaaS. And it seems like today we're going to focus in on that building Gen AI as a SaaS service, right? So what are the components of offering Gen AI model as a service? So where would you start if we were going to do that? And I think maybe you brought a slide for this too, right?
Yeah.
All right. So let's bring that up.
So, if you have seen SaaS solutions, probably you have seen something like this that, we call it like a control plane, or that's basically the brain of a SaaS solution. We have software as a service. Here we have AI, ML, or Gen AI or LLM as a service. So we borrow many of those components that are similar to other SaaS services, such as onboarding, such as identity, metering and billing, DevOps, management and operation. Those boxes you see in orange. But what makes this more specific to AI, ML, and Gen AI are basically two main services. One is for basically fine tuning. You have a model that you might need to customize it for each of your tenants, right? So each of your tenant, they have their own data that you need to build the model that represent that data, right, for that customer. So we need to talk about and we need to look at this from the fine tuning and model build pipeline perspective. That can have different configuration. You can have a shared model to serve all your tenant, or you can have a model specific and tenant specific model. So that would, and we need to look at it, and we will talk about this specifically. And the other aspect that is for inference. So inference is basically the main functionality of the AI ML. And then, we need to see that which configuration we need to, use for each of the SaaS solution. For example, you might want to have the same inference endpoint to serve all your tenant in one customer tier, or no, you want to have a premium tier that your tenant has a dedicated endpoint. And here we will look at the silo deployment. So if we focus on these two main differentiator for GenAI as a service, that would address to that SaaS aspect. The rest would be very similar to other SaaS applications, but these two are the main one that we need to treat them differently.
That makes sense. And looking at the slide that you have up, all of the common services around the edges are exactly the same as we might propose for a different SaaS solution. And then inside the box, that tenant-specific code, whether that's silo or pooled, really a lot of the same common elements that we would talk about building other SaaS solutions, but specific to the LML models themselves, right?
Exactly. Yes.
Okay. All right. So given this feels like we have enough background on what we're going into here. So are you going to show us how I can actually build Gen AI as model as a service on AWS today?
Yeah, sure. Yeah.
Nice. All right.
Let me go to my AWS account.
Nice. Into the demo already. I love it.
So yeah, and basically, you can go to your console, just search for Sagemaker, and then you basically landed here. AWS offer different ways of building LLM and deploying them. One of the easiest one that we usually recommend our customer to start with, it's called a JumpStart. And this has been around even pre-generative AI for many AI ML solutions that by like a few clicks you can deploy. For example, there is a pre-built solution for fraud management, for customer churn prediction. So if you can go there and then with a few click deploy them. And sorry, so might be I forgot to tell, like Amazon SageMaker is a managed AI ML platform. It means that many of the common AI ML tasks, such as training, inference, monitoring, log management, all are packaged and offered as a managed solution. So it's very easy and convenient to use them. And now we expanded this to generative AI.
Right.
So
And Mehran, if you don't mind me interrupting, I'll just call out to the audience that you've actually come on the show before and talked about SaaS tenant isolation using Amazon SageMaker. So even before we got to GenAI, you were already positioning Amazon SageMaker for use in SaaS, right?
exactly. And because, building a SaaS, it's not easy. There are lots of work involved for tenant isolation, for automation, pipeline. And we really want, our customer to focus on something that differentiate them from the competition. And,
Right.
instead of just building something that already exists. And SageMaker offer many features that support building a multi-tenancy into the AI ML, and that extended to like generative AI as well. So that basically purpose of this kind of AWS managed services to make it easier. And I will show you how easy it is to build some LLM and generative AI model. So you go to your SageMaker. There is a foundation model. This foundation model basically, those are the pre-trained LLM from many sources. What you see here are, for example, Llama 2, different version of Llama 2, that if you are familiar with and following LLM news, this is a very powerful open source published by Meta, Facebook, that it is already there. So it is the weight of the model, all the model artifacts are already there. So you just need with a few clicks to deploy it into an endpoint. Today, I want to mostly show you a model called a stable diffusion, which is from Stability AI. This is a model that's used for text to image. So it means that you describe an image by text, and this model generated for you. So but you can search, and there are more than the last time I checked was more than like 600 different models here. You can search by model name, or by your use case. So it will provide you some options, and then you can click that on view model.
Right.
So it gives you description about the model, what is that model is. And very cool feature here is that you can view the code into the GitHub. As I said, this is the open source, so there are examples there. And also you can open a notebook in SageMaker Studio. So SageMaker has a SageMaker Studio, which is a managed Jupyter notebook. Instead of you have a Jupyter notebook running on your computer, so you can have it as part of your SageMaker. And you can see here the entire code which you need to deploy that model is already here. So you just need to you need to identify the notebook environment, the kernel, the type of the model. But what you basically need to do is following this notebook scripts. And then if you do this just by clicking, it deploy the model on a notebook on a endpoint. Or you can do it even simpler. So there is a SageMaker JumpStart here. I click on the model's notebook. Similarly, I'm gonna look for a stable diffusion, which is the same model. So there is a deploy model here, right? I just need to identify the deployment configuration, which node I want. So depend on your traffic pattern. There are not, and these are all recommended ones that you can choose. So you identify that, okay, I want to get it from this ML P3 to X large. You assign a name to it. That endpoint name is basically the one that later you can connect it to an API gateway and call the model. So that's it. So you just click on deploy, and it's gonna preparing your model for you and deploying it for you. The same way you can retrain a model. So it says the model is ready, so that means the model is ready, but then the model need to deploy into endpoint. It's usually taking like a 5 to 10 minutes because what it does, it basically bring all those pre-trained weight and model artifact to endpoint that you identify. But you can do the same thing, and then you can train a model. uh, if I go there, so you see here there is a retraining. We will talk about fine-tuning LLM, but what you need to do, basically pointing it to a S3 bucket that has some training data. We will have a demo on that one as well, but you see how easy it is. You can do it through the code. If you are more comfortable with a notebook, you can see all the steps needed to deploy that model to an endpoint. Or if you are more comfortable, you can do it through the console. But with a few clicks, when that deployment is completed, basically you have an endpoint which is deployed for you. I have done it before, so I didn't want to keep you here waited. If we go back to the SageMaker console, there is a inference. I go to the endpoint, and you can see this one is the one that I just started to be created. It shows the status creating, but this is another one that I created earlier. So you can see all the information about it. I have tried it before, so it shows the CPU utilization, memory utilization, all the stats regarding the disk, GPU, CPU, how many time it invoked, the setting. You can have multiple version of the model, and then you can route different traffic. So here it says that all traffic go to this variant. If you have multiple variant, you can decide that I want 50% of my request goes here, another 50% goes to the another variant. And back to my very first comment, that you will get all these features out of the box. If you have done MLOps or DevOps, you know that how lots of work needed to build something like this. But here, with a few clicks, you can set it up. And then what you need to do, basically just focusing on that LLM, right? What it does. That could be your domain, your contribution, and let these things that it already built in to run as they run.
Right. And the LLM you picked, I mean, you were showing Llama in the beginning. It seems like there's a lot of them available, and you specifically went in and selected the stability. So why, is it something to do with the demo you're going to show? What was the reason for picking that specific LLM?
Yeah, so as you mentioned, there are many. If you go to the Hugging Face, which is an open source uh, repository for model, I think last time I checked was like a 100,000, 200,000 model, because many people, they take LLM, they customize them, and then they uploaded them there. So
Right.
a stable diffusion is very popular for text to image,
Mm-hmm.
and it's more it's more visual to see. And when we talk about the fine tuning, we can see that the model is fine tuned. With LLM, with those text based, so it's a bit harder to show, but the same concept apply to them as well. As I showed you, instead of using and choosing a stable diffusion, you can pick Llama or other LLM. So very similar conversations we can have with those models as well.
That's great. And up to now, we've seen a few different moving parts, right? So you created the LLM, you've pointed to an S3 bucket that has data, and you're showing an endpoint here, which I assume is how we're going to access this model in your demo, right?
That's correct, yes.
Right, right. And I think later on we're going to talk about the different types of endpoints. I'm not going to steal our thunder on that, but we'll put a pin in so people remember endpoints are one of the important parts of building this AI ML model as SaaS. So, you know, looking at all of this and remembering some of the previous episodes you had, AIML's been around for a number of years, right? We've been talking about it on the show for more than 2 years. So a lot of these models have been offered as a service before. You've seen you demonstrate it on the show before. Why is offering Gen AI as a service different than offering traditional AIML models as a service?
Very, very good question. So AIML has been around for many, many years. When pre last year, I think pre last November, when everyone has started talking about ChatGPT and LLM.
Right.
So most of the NLP model in this domain, was not very big. We were talking about uh, 50 megabyte, 100 megabyte, 200 megabyte in memory sizes. When we look at like a typical decision tree, like XGBoost, which is a popular one, rarely they get to that like 100, 200 megabyte of of the memory they require to be executed. But still, when we implemented SAS for AIML, that those model and those processes was considered heavy. In typical SAS, what we have a macro service that go to a database and do a query, right? So that could be very, very fast thanks to all these distributed and very powerful databases around. But when you have model, even forget about GenAI. So that model, that 100 megabyte model, that need to do an inference, right? That could take time, that need lots of memory. So by itself, AIML as a SaaS and as a service was expensive in terms of the memory it requires, in terms of the cost. Usually they need CPU and GPU. So mostly, now we are talking about the GPU, very powerful GPUs. Security is a big concern because, you are talking about customer data, right? So bringing customer data, do an inference. No, now everyone knows that how much data is important to everyone. And really, really the cost. So it could get very, very costly. These are very, very expensive instances.
Yeah.
So that was even for AIML, pre-Gen AI. Now we are talking about very massive in size LLMs, right? Like when we talk about the large language model, we need to define what is considered large language model. A definition which I like, it says that if a model is trained with more than 1 billion parameter. Okay, so that there should be a threshold, and there is no agreement about if you assume that a model that has billion parameter, if we consider that as a large language model, even that one. So there are lots of optimization technique, but we can think of that 1 billion could be translated in 4 gigabyte of memory. So even optimization could get to 2 gigabyte of memory. So just comparing that, 50 megabyte, 100 megabyte to a 2 or 4 gigabyte for a fairly, a small size LLM. When we talk about, Llama or GPT that has GPT-3 175 billion parameter. So you can see that how big those model and those instances, and then all these requirement regarding memory, cost, networking, CPU, GPU, you need to multiply. So this is, I'm telling my customer that if you are thinking that to offer AI/ML as a service, you need to have your system at a scale. Here, for offering LLM and GenAI as a service to your SaaS customer, you need to look at it at the extreme scale. So it is at another level.
Yeah. And I think when we talk about SaaS, we're already talking about a greater scale to begin with, right? SaaS solutions are designed to bring more tenants into a single solution. Now you talk about the scale you're talking about with LLM, it certainly presents some new sort of combined challenges of the two different concepts. Now, we have a really good question here that I think is going to lead us into the next part of the conversation, almost like they're reading our minds, thinking where we're going to go ahead to. So how does RAG-based enhancements of a base LLM model work in this SaaS case? So I think there's more than one option, but if you don't mind talking to the RAG option first, let's kind of go through those different options. but highlight RAG out of the gate.
And that's that's probably every most of conversation with the customer today are regarding RAG.
Mm-hmm.
That basically because the most practical use case that we can bring GenAI for enterprises into life is RAG. So just for the audience that they might new to RAG, so this is one way of fine tuning LLM. So you have those huge large language model that took days and months to be trained. One way is to retrain them, right? So we will talk about that later. You retrain them for a specific task for a specific customer, which need a good number of data point from your new use case or new customer, and it require good amount of training to customize and fine tune that model for a specific use case.
Okay.
Another way of customizing LLM to serve different customer, different tenant is using RAG. So RAG
Yeah.
is stands for retrieval augmented generation. And if you have work with ChatGPT or those chatbot, it's basically you can provide context, right?
Mm-hmm.
So you ask a question. For example, you provide a prompt and instruction that please summarize this email, and then you provide that email, and then that chatbot knows that okay, I need to do that task summarization on this context, right? So this is basically in RAG, we extract some information that we know that are relevant to that question, right, to that prompt, and package them as the same prompt, and giving it to the LLM, which is the same LLM. So we don't do customization, but we provide more context here
Right.
for LLM, and then LLM look at that context and perform that task. Okay, so this really help because then we don't have to, if you have 10 different tenant and each of your tenant has their own data set, which if you look at the slide I have, for example, for two tenant A and tenant B, they have their own data that could be a store in S3, could be a store in a database, in a data warehouse. So as a SaaS provider, you need to have isolation policy to just don't mix your tenant data together. You keep
Right.
them, and then when there is a query, you need to you look at when uh, there is a request for a specific tenant. You need to
Mm-hmm.
go there inside that tenant knowledge base and extract those information which are relevant to that query, bring it as a context, and then giving it as a as a as part of that prompt plus query plus context to the LLM and get the response back. So this is
Right.
one way of customization. So I didn't show it here. This is more conceptual, but what we will see customers using is vector databases, right?
Yeah.
uh, OpenSearch, PG Vector, Pinecon. So they are very good vector databases that help to vectorize and using embedding to store those knowledges, not
Right.
those knowledge bases. So when there is a query comes, we do a similarity search, extract those contexts which are relevant to that query, and giving it as a context to LLM and get a personalized and get a customized response back.
Right. And I think you've actually answered the follow-up question in the process of this answer. And this slide demonstrates it really well. Does it go against the three basic principles of SaaS, of having no specific tenant version? So whenever we can avoid it, you don't want to have customizations that are specific to a tenant. But looking at this, it's really the data model that's tenant specific, right? So your LLM is as some shared aspects to it, but you're grabbing the context out of the individual tenant's data. So I think now, would you say that you've already sort of answered this question based on that, or do you think that there are some tenant-specific configurations or versions to this?
So the tenant configuration, if you go with the RAG, so we
Hmm.
keep LLM, intact because
Right.
LLM is expensive.
Yes.
So retraining it is expensive. And just remember, if you retrain it, then you need to have a separate version and separate copy of that LLM running for that specific tenant,
Right.
right? So you cannot take advantage of this economy at a scale for these very expensive resources. So
Yeah.
this is why RAG is very popular because
Mhm.
you can share the same model with different tenant, but different tenant they can have different configuration, but all those configurations would be given as part of the query and as part of that prompt to LLM. So
Right.
you can set for example for this specific tenant be more uh, factual and the other one could be more friendly, right? Could be even you can just do some imagination. So there are some configuration, but they are all be part of this prompt engineering. So that's going
Right.
to be a RAG plus prompt engineering to get a response that would match better with your tenant request.
But based on what you're saying and the fact that we said we were going to do an image-based demo, I assume we're actually not going to be using RAG or prompt engineering today. So that it's great questions, and I love diving into this though because it's really interesting that there are these different models. But I think we probably are going to talk about fine tuning today for this demo, right?
That's true. Yeah. So we can have it probably next time. We can look at the RAG as well.
Right.
But so RAG, mostly would be focusing on the data pipeline because you need to look at the vector databases. You need to look at the embedding, and how could be a very interesting session by itself.
Hmm.
And when we look, and so not all the models are fine tunable. Usually you can use RAG with LLM, which are like text based, because it's much easier to provide the content and as a context to
Right.
LLM that generate text. When we look at the image generation, and they usually take, uh, you know, uh, you can provide the image, and then ask to do some some customization on that image, or you can retrain. And retraining of the LLM that generate uh, image are very common and very easy to demo. So that's why I picked that one. And what I put here in a SaaS, if you want to do fine tuning, right? So we talk about RAG. RAG has many applications and which are very popular, but there are use cases that need fine tuning. There are pros and cons for each of them. The cons with RAG is that you need to provide context every time, right? And LLM, they usually charge you per token. So let's
Hmm.
imagine that, if you want to send the chat history, right? So every time that you provide question and you get answer, it add to your prompt. It means that it would cost you more. So if every time that you want to query LLM, you have to send a very lengthy context that are relevant to that query, so it costs you, right? And then it would take longer to process, and it could be more expensive. But here in fine tuning, you will get that retraining done one time, and then you don't need to provide that, right? So that's already built into that retrained model. So we really need to look at case by case.
Hmm.
RAG is getting more attention because of that, leveraging economy at the scale, but there are use
Right.
cases that they need fine tuning. What I put here is for a SaaS model. Really, what important in building that fine tuning mechanism is implementing a pipeline. Because that fine tuning in a SaaS need to be done many times, right? So it's not just one time. So you need to repeat the same training process for each of your tenants, even more than once. For example, like here you have two tenants. Each tenant they upload some data. That data
Hmm.
go to the Lambda function, and that goes to a S3 bucket that we can have isolation here. So the tenant data are isolated. As soon as tenant data are injected into that S3 bucket that trigger another Lambda function, and that Lambda function start execution of a training pipeline. So SageMaker offer a managed pipeline, which is a workflow. So you can define different steps for pre-processing of your data, for training of your model, evaluation of your model, registration of the model. Very simply, you can put them into a workflow order and then define that as a pipeline template. So that's the beauty of SaaS, that we can leverage the same source code for different tenants. We identify the same pipeline template, but we inject enough parameter to customize it for each tenant. So that one parameter could be the location of that tenant S3 bucket, right? So we can use, when we invoke that SageMaker pipeline, we pass that, okay, this is a location of that S3 bucket, and just use data from that bucket for tenant A. For tenant B, we invoke the exact same pipeline, but we pass the location of that S3 bucket for tenant B. So that this pipeline, they both can be executed in parallel. And when the pipeline execution is done, which is basically that fine tuning of LLM is done, and just combine this with that JumpStart that I showed you, right? So there are, for all those models, they are pre-trained, available in AWS. The images are available in AWS image registry. So you can point your step to those, that we have SageMaker JumpStart. So you can point it to the ECR, which is Elastic Container Registry. So the image is there. The pre-trained weight are in S3. So all those assets are there for you. So you just need to, run a few steps here to fine-tune it based on your tenant data. Training is done. The model artifact will be stored again in S3, and the model is registered for this specific tenant into the model registry. I want you to look at it and see that, how many of those multi-tenancy aspects are here, are already available for you. If you use SageMaker, you really don't need to build the concept of pipeline. The SageMaker registry, it supports multi-tenancy. It means for every tenant, it provides you a model, a category that you can store, or a catalog that you can store the model belonging to that tenant under that catalog with different versions. So all these features are already there. This pipeline can be executed at any scale. So there are some soft limit, hard limit, but that can be executed at any scale in parallel for you. So this would be very efficient to be implemented in SageMaker.
So there are some questions popping up. I want to try to bring some of them up. Some of them, is it going to be expensive? I think we'll defer till later. We'll talk about cost a little bit later. But is it possible to create a tensor input-output database and reuse those like caches? This is I don't know if we can answer this one on the spot. How do you feel about this one?
So the question is that, is it possible to create just bring some caching mechanism?
Yeah.
So yeah, and that's a very good question. When we look at inference, what the caching here means that if you provide the same request, you get the same response, right? And that usually many customers, they putting a caching layer in front of their endpoint, which is fully supported in SageMaker. And then if you get the same request, so you don't keep your in endpoint busy, right? So it exactly just return, and that would help with. But one problem here is that just think about the chatting. So every request could be different. So you really need to look at that efficiency, that how many new requests you get versus how many previously seen requests you get, and then you decide that adding a caching layer would help you, or it would add another overhead and another cost factor.
Okay. There's another question here. It gets very specific about Redshift. Does it support scalable KNN vector storage? I've seen blog posts suggesting OpenSearch, which I think does do KNN, or RDS with PG vector. I'm not sure if you'd be familiar with all of the solutions that are available in that space, but can you specifically answer the Redshift or?
Yeah. So Not sure about that.
Yeah.
That's something I need to check. But yeah, so open search is a very popular one that many customers are using today, and PG Vector.
Right.
But yeah, so Redshift not as if I can remember correctly.
Yeah, Jakshed, feel free to reach out to us offline. We'll try to get you an answer on to that if you are so inclined. And one more before we move forward. I think we've got another demo to get to. AWS image registry for container images or models.
So for you do container registry, right? So for the image of the model, and then for the training for the training code and also the inference code, you can have that image also part of that container registry. So would be both of them.
Okay. All right. And with that, I'd kind of like to see how AWS supports these different LLM customization models, particularly fine tuning. I know we sort of zoomed in on that because we want to do image processing. So do you have a demo that you can show us that demonstrates how that works?
Yeah. So let me bring it up.
Oh no, the dreaded sign out.
So it should be okay here. That's
okay.
The notebook is up and running.
Okay.
So if you can, so I'm using some GitHub projects that's available. So you can everyone can look at them. So the first one is for fine tuning,
Okay.
and if you want, you can post the link. So in this basically demo, what I want to show you is a notebook that fine-tune that stable diffusion, the model. So we want to see that what does that fine-tuning look like. And again, just look at how easily with the minimum number of script that you run, you can fine-tune a model. So we have already deployed, right, or model. So I'm just gonna concentrate more on the script that are relevant. But basically, we are doing a number of imports, adding log mechanism. I have already pre-run because some of the steps could take time, but you will get very similar result. So in AWS, if a service wants to talk to another service, for example, SageMaker wants to talk to S3, which is our object storage, we need to set a rule, like IAM rule. So that we set it up here. We set the region, the SageMaker session we do. So here, number 6, we get the list of JumpStart model. So remember I showed you that, so there are, like here, it shows 524 model already registered into that JumpStart. It means that all those 524 available, and you can do the same and deploy them. Here, I filter them for this text to image for this kind of use cases, and it shows me these models that are available here. I pick one, which is that stable diffusion. You can set a model version. I set it to the latest one. And I set the scope for training. So I want to retrain this model. Then, we can set a instance type. I'm picking this MLG4DN2X large. That's recommended for training. So there was a question regarding the image. So this is a training image URL from the ECR that we are extracting here. And we need that was the image URI for the training, the training source code, the model image, and also the data, right? So we need all these 4 pieces to retrain a model. So the data we use here is this cat. Let's assume that you build this for your customer, and each customer, they want to customize it based on their different type of cat that they have, right? So I know it's a funny example, but it's easy to show.
Cats are always good examples.
So we have these cats available here in my local notebook. So what we need to do is basically moving and uploading them into the
Yeah.
S3.
Okay.
Because it's good to know that SageMaker, they can get data from S3 and write data to the S3. There are like a few more options too, but your data, for example, in this case, need to be in S3. So
Right.
we identify a path here, and then basically moving that data from local to S3.
Right.
So setting some hyperparameters for retraining. Each model can have its own hyperparameters. Then what we do here is creating an estimator object. So estimator is a managed training in SageMaker. You pass all these variables that we have defined, for the role, for the image, training image URL, the training source URL, the train model URL, the data, that training data in those cat images in S3, and some hyperparameters, right, that we have defined. And that's it. You call the fit function on that estimator from that estimator object. Then it goes through that retraining. So, for example, in this case, the retraining took 27 minutes. And now we have a fine-tuned version of that stable diffusion. How we can test it? First, we need to put them into endpoints, right? We have the model ready, which is fine-tuned. Now we want to deploy it into an endpoint. So we define now the scope is inference. This is the instance type. I want to deploy it to this ML G4DN2X large. Uh, Again, retrieve that model, retrieve the inference code. So for these models, the inference image also available in ECR, assigning a name to it, and then calling deploy. So calling deploy by passing that, I want one instance of that. You can have more than one instance if you want. You can define a type, which I've already defined. This is the entry point into that source code. The image of that, of that model, and then assigning a name. So this is going to take time, 12 minutes to deploy to that endpoint. And now we have, a working endpoint that can get prompt and generate responses. How we can test it? We pass a prompt, for example, here, Rio Burger Cat, which is that object that we have retrained a model in a space suit. So, you can see that this is basically very similar to that, our own cat. Another example could be, Rio Burger Cat animated and dressed as a police officer. So this is a prompt, and remember that's the language that we talk to LLMs, right? We define a prompt, and then I call invoke endpoint by passing the endpoint name. That's the name that we assign to the endpoint, and by passing this prompt. This is a prompt that we define, and then we get the similar or cat in that prompt.
Cats
So
always works. Always makes a great demo. It's awesome. So these are great. It's really interesting to see how these work. But do you want to kind of get into the Gen AI inference side of this thing? So you've talked before about AI/ML inference in general, but now with Gen AI, does the inference get a little bit different, or there's some different aspects that we have to think about, especially for the SaaS model that we're bringing?
Yeah, and like there are many customers and interested in training and fine tuning, but all the customer and use cases, they need to look at the inference, because without inference there is no use case for ML, right? So you really, that's the part that's very important. We already talked about the size and complexity problem, right? What we need to do, and usually that comes for all those inferencing, is optimization. When you have it, if for SaaS, for SaaS, you are talking about many inference requests coming, um, because you have, it's not built to serve one customer. In SaaS, you build your system to serve multiple tens, hundred thousands of customers. So what important here is customization as optimization. Uh, when you talk about uh, large generative model inference, always that optimization talk would come into picture. There are different methods for compilation. You use a very highly optimized compiler to compile your model. You can compress your model. There are different techniques, quantization, pruning, distillation. So, basically, you can minimize your model by removing some parameters, or you can, like in a typical model, it is trained for a full precision of like a 4 bytes, 32 bits. That can be reduced to like 16 bits or 8 bits to have less memory requirement. There are techniques for model partitioning. If a model cannot fit into the one GPU, so you can have it into multiple GPU, and using like prompt engineering to really send more targeted prompt to that inference. So always think about, when you want to have inference at a scale for SaaS solution, that optimization, without optimization, probably you don't have a use case. So you really need to look at optimization, and there are lots of help in like SageMaker. There are different container, for example, deeper speed or faster transformer, Hugging Face Accelerate, that can take your model and optimize it and bring the size down, and then memory requirement lower latency, and can help with inference.
Nice.
After you're done with this, after you optimize your model, really in SaaS, we have it like a two question. Do you want to have a dedicated endpoint for that model? That could be you have to, because still your model is too large. You cannot fit more than one instance of that model to a single endpoint. But in some cases, you can have a one multi-model endpoint, and you load tens or hundreds of model into that endpoint. This is a very good feature of SageMaker that's called multi-model endpoint. I've seen SaaS companies that they are leveraging of this for GenAI or non-GenAI model. How it works, simply you create a model endpoint that point to a S3 bucket, and you store those model artifact into that S3 bucket, and then model that MME endpoint. When it see a request coming, it see if it already have that model loaded, then it serve that, right? It respond to that inference. If it doesn't have that model loaded, then it go to the S3 and load that model. So it provide a managed load and unload mechanism, and you can share the same endpoint for multiple models.
Right. Now, I know we don't have too much time left. We only have about 6 minutes left, but I think you have a multi-model endpoint demo. Do you think we could speed through it in time? You think we can make it? All right, let's go for it then. If there's cats in it, I want to see it. I've got to see it. So let's do it.
Exactly. So, hopefully you have shared that GitHub repos. And so what we have seen so far, we fine-tune a stable diffusion model. Now let's assume that you have a number of them, and we want to load them into a MME endpoint, right? So you have, in this case, I have like 4 different version of a stable diffusion. Let's assume each for serving one tenant, and we want to load all of them into the same endpoint.
Okay.
So this is a notebook. So you installing all the requirements. I'm not going to go through it. Very, very similar to the previous setup. Here, I'm pointing to 4 different model, right? So I have a diffusion, a stable diffusion base, depth, in painting, and upscaler. So each of them, they do something specific for the prompt, right? But these are 4 different versions of a stable diffusion.
Right.
What it does, it brings them from the Hugging Face. It downloads them and store them into the S3. Then, so MME, it is based on the Triton, NVIDIA Triton inference container. It is fully supported. But in order to support LLM, we need to add and bring like an environment, which basically like a Conda environment that has those extra library, which is required. So we set up that environment. And let me pass this.
Fast forwarding the demo with 5 minutes left. I love it.
So what we need to do here, we need to bring the Triton image. What you see here, for every region, we have a different ECR, and then we will get that image, MME Triton image URI. So we have it here. Then those we have downloaded those checkpoint of those for stable diffusion model, right? MME required them to be in a tarball format. So here we just zip them and put them into the S3. We build a container based on that image.
Right.
And then we create a model based on that container, using that image URI. Next step is, and this is very similar to all other, if you build any other model, we will follow this. We create a model, we create an endpoint configuration. So you see that I create an endpoint configuration, and then we deploy. So we create an endpoint. At this point, we will wait until this endpoint is in service, and that's good. We have MME pointing to a S3 folder which has 4 tar files, each one representing one model. We do just one empty dummy prompt to basically loading that environment that I talked to that's required to run this stable diffusion. But here, look at this. So I'm sending a prompt, infinity pool on top of a high rise overlooking Central Park. You can provide a negative prompt. But then I'm setting this target model. I identify which model should be invoked to process this prompt. So SD based here. So here you see a very high quality image generated here. For the next tenant that they want to do like a depth, the model that's very like a detailed oil painting, this kind of prompting. So I want to target to another version, still the same endpoint. That's really the goal here to show. So you can see here it's more like oil painted, right? So we are getting a different result. The third model, going to the in paint, that's another version of a stable diffusion. And here we want to have a mask. So we introduce a mask. If you see there is a mask image, that the mask image basically masking this tree, and then replacing a tree, and it's very natural, right? So
pretty brilliant, yeah.
And then the fourth model is upscaling. So we provide a very low resolution image, and it does upscaling and adding more resolution here. So
Nice.
The same endpoint, 4 different versions of the same model, and so each model can be represented for one type of tenant. But just look at that economy of scale. Very expensive GPU is shared between all these 4 models.
All right, Mehran, it's been incredible. This has been an awesome episode. As always, we really enjoy having you on the show. Thank you for staying up late to be with us here in the APJ time slot. But for our audience, this will be the last episode of the season for the APJ time slot. We will be back again next week in the East Coast time slots for EMEA, for Europe, and the East Coast friendly times. For that episode, we're going to have on the SaaS competency partner, Clean Slate. We're going to talk about building custom authorization platforms with serverless, leveraging Okta. Until then, it was great having you all on. You've been a great audience, and I will have a great rest of your day. Take care, everybody.
Thank you. Bye.